All right, well, we are looking at composite transformations today. Now, a composite transformation, composite transformation is multiple transformations. And so that is possible. You don't just have to perform a reflection. You could do a reflection and then a translation, or a reflection then a rotation, or you can do multiple transformations. This is what I'm saying. Now, if we do a composition of two isometries, if you do a reflection and then a translation or whatever, two isometries, it's still an isometry. Okay? It's still going to be congruent to our original image. Here it says reflect ABC across line M and then translate it along vector V. Now, it's important to note here is that the order does matter. First, we're going to reflect it across line M, like so. So we reflected across line M, reflected it, and then we want to translate it that distance in that direction. And so we do that distance from B to B prime, right there. That distance from A prime to A double prime. That distance from C prime to C double prime. It was reflected, and then we translated along that vector. The composition of two reflections across two parallel lines is a translation. Okay? If we reflect across two parallel lines, it's the same thing as a translation. Notice here, we're going to take this segment, we're going to reflect it across line C, and then we're going to reflect it across line D. Knowing C and D are parallel, reflect it once, reflect it again. Notice R to R prime is the same distance from R to R double prime is the same distance from S to S double prime. So we reflected it, we reflected it again, we performed a composite transformation. We're just saying that if we reflect across two parallel lines, it's the same thing as just performing a translation. We can perform reflections across two intersecting lines. The composition of two reflections across two intersecting lines is a rotation about the point of intersection. The angle of rotation is twice the angle formed by the intersecting lines. Notice here we have this quadrilateral, we're told it's a rectangle, STUV. We want to reflect it across JK, and then we want to reflect it across LM. So we know it's going to be the same thing, it's going to look the same as a rotation. So first, if we perform that reflection, we reflected this across that line. We want to reflect it across LM. We reflect it across LM. Notice that this is the same as if we were to take this and perform a rotation amongst all those points. Here we want to perform transformations on this rectangle, and we have a certain order. We want to reflect it across a vertical line. We want to rotate it 90 degrees clockwise, rotate it 90 degrees clockwise, and reflect across a horizontal line. So let's take a look at this. So first we perform that reflection across our vertical line. Then we perform that rotation 90 degrees clockwise. We perform another rotation 90 degrees clockwise, which would have been the same thing as rotating 180 degrees clockwise. But we did each one in the order they said. And then finally we reflected across a horizontal line, which gave us J quadruple prime, K quadruple prime, and so on there. So we can see our result. And we want to perform these transformations on a rectangle. Same transformations, but a different order. Reflect across a vertical line, rotate it 90 degrees clockwise, reflect across a horizontal line, then rotate it another 90 degrees clockwise. Different order. First, our reflection across vertical line, we're starting the same as the last one. Then we rotate it 90 degrees clockwise, we reflected across horizontal line, we rotated another 90 degrees clockwise. And look at these two ending figures here. Here's our first one, here's our second one. They were the same transformations but a different order, and they produce different results. So the order of our transformations does matter. okay? These are still congruent to the original, but where our corners are, it's not exactly the same position, okay? It's the same shape, same size, but we get a different position. So the order does matter for a composition. All right, final example to create a design. Reina draws a line segment and reflects it twice as shown. The reflection lines are parallel and are 1 inch apart. Find the distance from A to A prime. Well, we know that if the distance of our segment right here, the vertical distance 1 inch, it's going to be another 1 inch right here. So from A to A prime would be a total of 2 inches. Not too crazy right there. Reina, I think you could have figured that out.